Part of homework 1 has a vector review on it, so I thought I'd do one of these kinds of problems for you just to get things started. Okay, so let's look at problem 14 from chapter 3 in Giancoli. It's very similar to the one that's assigned in the homework. It says for those same vectors that I've drawn right here, first of all, part A says, what is B minus 2 times vector A? If you remember, when you multiply a scalar by a vector, all you do is change its length, unless it's 1, and then you don't change it at all. In this case, we've got B plus, the scalar is minus 2 times the vector A. Okay. So the negative sign flips the direction of the vector, and then the 2 makes it twice as long as it was. So let's just graphically see what this looks like. We've got B, looks like that. That's the first chapter of our book, or whatever. Okay, and then we need to subtract 2A. So if it was plus 2A, it'd be off in this direction. Since it's a negative, it's off in this direction. There's 1A, there's 2A. So this is minus 2A over here, and this is plus B. Okay, so our resultant vector, what we're looking for, is going to be from the beginning of this series to the end. And let's call it C. Oh no, we can't call it C. Let's call it D. Okay, so D is equal to B minus 2A. Alright, well the first thing we want to do is split these up into components. So let's find the x component of B and the y component of B. I don't know why I'm starting with B. Okay, well it was the first vector here. Okay, so the x component of B is right in here, and the y is right here. If you remember from trigonometry, the cosine of 56 degrees here, that's the angle in here, is going to be equal to the adjacent, which is bx, over, that's an x there, sorry, bx over the hypotenuse, which is b. So look, from that we can find out what bx equals. Just multiply both sides by b, and you get bx is equal to b cosine 56 degrees. Okay, do the same thing with y and the sine function, and you get by is b sine of 56 degrees. Okay, ax is going to be a times the cosine of 28 degrees, and ay is equal to a times the sine 28 degrees. Now, one thing that I forgot to do, by points in the positive y direction. See, that's increasing y, and this is increasing x. But bx actually points in the negative x direction, so we actually do need a negative there. With that though, you can plug this into your calculator, you get some number out, and the units don't have any dimensions, so you just plug it into your calculator, write down the numbers. Why this is powerful is now we can say dx, actually let me swap colors to keep this a little bit better organized. Let's look at D here. This is the x component of D. This is the y component of D. And now, to write down the x and y components is really simple. You just come back to this equation, and instead of writing vectors, you just put the subscripts that you need. So it's bx minus 2 times ax. If ax is a negative number, then you'll have negative and another negative, it would be positive. In this case, ax is positive. bx, though, is a negative number. This makes sense from the figure that we drew, right? The x part of b is in the negative direction, and both of these minus a's are giving us even more negative x. So this will be a negative number, this will be a negative number, and you'll get dx is some big negative number. dy, similarly, is just by minus 2 times ay, which all of these are just numbers. They shouldn't scare you. Okay. Plug those in, you get some number for those. Okay, if we want to find out how long vector d is, we can realize that this is a right triangle, and the Pythagorean theorem tells us that the hypotenuse squared is equal to the sum of the sides squared. So dx squared plus dy squared. Solving for just the length, you get that it's equal to the square root of the sum of the squares of the sides. Okay, to find the angle, I'm going to define that as theta for d. As long as it's clear how you've defined the angle, you could call it this angle. Some people might like to be more conventional and start from the x-axis and call that some angle phi or something and use that instead. As long as from your drawing it's clear what angle you're using, then you're fine. Okay, so the tangent, I'm going to use theta. The tangent of this angle is equal to the opposite over the adjacent. So dy over dx. Take the arctangent of both sides to get theta. Theta is equal to the arctangent of dy over dx. All right. This is the magnitude. This is the direction. It's completely solved now that we've got both of those. That's all you need to define a vector. Let's see. Anything else we wanted to... Oh. Notice, though, that here the signs kind of get confusing when you're doing this kind of stuff. Because of the way I defined this angle theta, I don't want to plug in a negative value for dy or a negative value for dx. In this case, it turns out not to matter. But because of that, because if you've defined it as this inner angle, then you just use the magnitudes of dx and dy. Okay, that's part A. Let's go on to part B. Actually, where do I want? Okay. Well, we won't do the solving for components like we did on part A, just because it's the same. So once you've solved for ax, ay, bx, and by, you don't need to do that. And in fact, cx is 0, cy is minus 31. You can just see that there's nothing in the x direction from vector c. It's all in the minus y direction. Okay, so part B says we want to find the value of the vector that is 2 times vector A minus 3 times vector B plus 2 times vector C. Alright, and we will call this some new vector. We already used D, so let's call it E. Alright, let's draw these again. So 2A will take us from here to there. That's 2A. Minus 3B, so it's in this direction. 1, 2, 3. And then plus 2C, which is in the minus y direction. So there's 1, 2. Alright, so that's all of this stuff, and it's equal to this new vector that we called vector E. Again, you've got an x component for E, it's right here, and a y component right there. Call this, I don't know, theta E or something. We already used theta for D, but hopefully that's not too confusing. It's a new part to the problem. Okay, and now EX just equals 2AX, and you can use that from part A, minus 3BX, again from part A, plus 2CX, which we already decided is 0, so we can just ignore that part. EY is 2AY minus 3BY plus 2CY, which you can ignore the subscript because CY is just the length of C. Okay, you do that same thing. Once you've got EX and EY, the length of E is just the square root of EX squared plus EY squared. And the direction, theta E, is the arctangent of EY over EX. All right, and those are enough to specify the vector completely. All right, hopefully this is helpful, and I'll see you next homework, I guess.